Hi, I'm Ms. Boom. Let's explore graphs of the form y equals x minus h squared. Example 1, we're going to refer to x squared as our original graph, and we're going to observe what happens when we change the value h. So let's say h is 2. Now notice that h is positive 2, and into that format it looks like x minus 2. Be very careful with that. So h is 2, positive 2 in this example. So we can draw a table and find our y values. So we can say when x is 1, sub that in, we get 9, minus 1 minus 2 is minus 3, squared is 9. When x is 0, we have 0 minus 2 is minus 2, minus 2 squared is 4, etc., etc. And we can plot these. So this is x squared, and when we plot the other graph, we obtain this red line there. Let's observe the characteristics of this graph. The y-intercept can be calculated when x is equal to 0. Just double check. We get 4. Yes, we have 4 there as expected. And for the x-intercept, we can see that the graph has moved to the right. So it's now at 2, 0. The axis of symmetry has now moved. Remember when we changed the value after x squared or the dilation, the axis of symmetry didn't move. But this time, when h changes, the axis of symmetry has moved the same way. So it has moved to the right by 2. It's now x equals 2. And the turning point has also changed. It's now at 2, 0. So whatever the value h is, in our case 2, the x value of the turning point is also that value. So we describe this graph as having moved to the right. And we know from the last lesson that the word move in mathematics is translation. So when h is positive, the graph moves or translates to the right. We can see each of the points have moved the same amount, and in this case, 2. Example 2, what happens when h is negative? For example, negative 3. When h is negative 3, our equation is x minus minus 3, which is x plus 3. When that happens, our graphs will move to the left by 3. So double check our y-intercept. When x is 0, we have 9 up there. The x-intercept, we can work that out. When y equals 0, it's negative 3. So the graph has been moved to the left by 3, and so the axis of symmetry is also negative 3. And the turning point, again, the x value is also whatever the h is, so negative 3. We describe this graph again as having been translated to the left by 3. What happens if I have a negative graph and a positive h? Remember, h is 1 there. X minus 1 means h is 1. So we can work out the y-intercept, substituting x equals 0 into that. We get y equals negative 1. We can plot that. And we can find the x-intercept by substituting y equals 0, and we would get 1, 0. And the graph will look like that. So the axis of symmetry is at 1 this time, and the turning point, the x value of the turning point, is also at 1. And we describe this graph as having been translated to the right by 1 because h is positive. Example 4, last example before I test you. Here we have a negative graph and h is negative 2. Remember, h is negative 2, so minus minus becomes plus. Here we can work out the y-intercept by letting x equal 0, and putting that into the equation, we have y equals negative 4 as expected. And we can work out the x-intercept by letting y equal 0, and we can work it out to be negative 2, 0. The axis of symmetry is at x equals negative 2, and the turning point matches the h. The x value matches the h. h is negative 2. The x value of the turning point is also negative 2. And we describe this graph as having translated to the left by 2 because h is negative. Here are 4 graphs and 4 equations. Let's see if you can match the equation to the graph. So here we have a positive graph and it has been translated to the right, so h is positive. Here we have a negative graph and it has translated to the right, so h is also positive. Here we have a positive graph, but it has been translated to the left, so h is negative. And here we have a negative graph and it has been translated to the left, so h is negative. Let's have a look at the first equation. This is a positive graph and the H is positive, so it's moving to the right. So that graph belongs there. This one is a negative graph and the H is positive, so it's that graph there. This one is a negative graph and H is negative. Remember, negative becomes a positive. So that belongs to that graph there. And here we have a positive graph and H is negative, so moving to the left. So when H is greater than 0, we have moving to the right, and it looks like minus in the equation. And when H is less than 0 or negative, we're moving to the left. And inside the graph, it looks like a plus sign. Bit confusing, be very careful and memorize this. When you see a minus, that means H is positive to the right. When you see a plus in the bracket, it means H is negative, moving to the left. Okay, revise this and I'll see you next time. Thanks for watching. Bye.